Hello guys, welcome back to the Maths Club. This is Paul Ayub, your mathematics instructor. In my last two videos, which I posted on all my social media handles, I showed how we could apply the knowledge of differential calculus to obtain tangents and normal to a curve at a particular point. Today, I want us to understand how to integrate functions. And in order for us to do that, I have decided to choose IB Mathematics Analysis and Approaches Higher Level Question on Integral Calculus. So ladies and gentlemen, join me and let's walk through the solution of this question on integral calculus on the board. So if you can, as you can see on the board, we are given that we should evaluate the integral from 0 to pi all over 2 of sine 2x all on 1 plus cos squared x dx. So this is actually integrating a rational function. Now, when you want to integrate a rational function, first of all, verify whether if you differentiate the denominator of the function, it will give you the numerator. If you realize that when you differentiate the denominator, it will give you the numerator, you just take the ln of the denominator. Take note of that. In this function, we cannot differentiate this denominator and it will give us the numerator. So we cannot apply recognition. So after you have realized that you cannot differentiate the denominator to give you the numerator, you also verify whether you can express the fraction in terms of partial fraction. So you see that this fraction cannot be expressed in terms of partial fraction. You can also verify whether the denominator can be expressed as a perfect square. As you can see, this denominator cannot be expressed as a perfect square. So when these three different methods cannot hold for a rational integral, the method that must go for that integral should be substitution. So as you can see, I'll proceed by using substitution. So I will say let u equal to 1 plus cos squared x, which implies u is equal to 1 plus cos x. You can write it like this, all squared. I can call that equation 1. So I'm using u to replace everything in the denominator so that it will be easier for us to handle this function. So we want to change from anything x into u. So we want to change, the idea is that we want to change everything here from x to u to make it easier for us. And in order for us to do that, we have to replace dx. So we will differentiate this relationship and make dx the subject here so that we fit it here. So take note, we have to replace dx, then we have to change the limits also. Take note, when you are using substitution for definite integral, you must change the limits because these limits are with respect to x. Since we want to use the variable u, you must also have limits with respect to u. If you use the same limit with the variable u, it will be very wrong. So I proceed first of all with differentiation. Du on dx, the differential of 1 is 0. This one, we have a function inside here raised to a power. They call it function of a function. So what you do is you just do three things here. When you see function of a function, you bring down the power, which is 2. You differentiate inside the bracket. The differential of cos x is negative sine x. Then you subtract 1 from the power, which will just give us cos x. So if you look at the three things I have done, first, second, third, you bring the power down, differentiate inside the bracket, subtract 1 from the power. We have this. But if you realize, so our du on dx is actually negative 2 sine x cos x. Du on dx is equal to 2 sine x. Recall from trigonometry, 2 sine x cos x is the identity for sine 2x. So this is negative sine 2x. So recall I said we have to replace the x here. So for us to do that, we must make the x a subject to stand alone, a subject of formula here. So du will be equal to negative sine 2x, dx comes this way. So that implies negative 1 all over sine 2x du should be equal to dx. So you see that dx is already made a subject of formula, which is what we are going to use to replace here. The next thing we have to do is to change the limit. So you see that when x equal to 0, when x is 0, the lower limit, what will be my u? U will be, you substitute 0 for in the place of x. So it becomes cos 0 here. Cos 0 is actually 1. And when you square 1, it's actually 1. Plus this 1 will give us 2. So when x is 0, u is 2. When x is pi all over 2, u will be, you substitute pi over 2 in the place of x now. So this thing u become equal to 1 plus cos pi over 2. What is cos pi over 2? Cos 90 degrees is 0. When you square 0 is 0 plus 1 gives us 1. So when x is pi over 2, u is 1. Therefore, this implies the integral from 0 to pi all over 2 of sine 2x all over 1 plus cos squared x dx becomes the integral. You see that when x is 0, u is 2. So down here we used to be 0. When x is pi over 2, u is actually 1 sine 2x all over. Recall, u is equal to 1 plus cos squared x. So it means the denominator of this fraction has to be u. So we have u under below here because 1 plus cos squared x, is equal to u. So we replace the u there. Times dx. What is our dx now? Dx is negative 1 all over. Dx is negative 1 all over sine 2x times du. So if you realize sine 2x and sine 2x can cancel, numerator cancel with denominator, so that our integral becomes the integral from 2 to 1 of negative 1 all over u times du, because these guys are cancelled out. Now there's a property of integral that says when you see a negative sign and the lower limit is higher than the upper limit, the negative sign can be used to reverse the limit. So it means this thing now becomes the integral from 1 to 2 of 1 all over u du. You realize that the negative sign is no longer there because it has been used to reverse the limit. Now, what is the integral of 1 all over u? Recall I said if you differentiate the denominator and it gives you the numerator, then you have to take a ln of the denominator. Now, what is the differential of u? Is 1, which gives us the numerator. So it means this integral is just the same as ln u from 1 to 2. So substitute your upper limit here and also substitute your lower limit. When you substitute your upper limit, you can ln 2 minus. You substitute your lower limit, you can ln 1. Then we know that ln 1 is actually 0. Ln 1 is 0, so it becomes ln 2 minus 0, which is just ln 2. So the answer, the solution to this integral is actually ln 2. So, ladies and gentlemen, that is how we can integrate rational function. So if you are seeing me for the first time, like, share, comment, and follow me so that whenever I drop updates, you will be having them in real time. See you next.